Hi guys. So in this video, I'm going to discuss about population growth. Was that good English? Not really. Good way to start off the video. Let's start from the top. Hey guys, in this video, I'm going to discuss the topic of population growth. So we're going to be looking a little bit at how we assess the rate at which population size is changing. And then we are going to talk a bit about carrying capacity. And those are the two things on this video's agenda. So if we look at this cute circular model that I have here, we're looking at the four factors that are impacting the population size of any given area. And so if we take a population and we look at the amount of births, the amount of deaths, the amount of immigration, and the amount of emigration, we can assess how many individuals the population has gained or the population has lost over a given amount of time. And that given amount of time can be established by whoever is doing the research. Okay, so this could be by hour, by day, by year, by month, by duck quacks, doesn't matter, right? It just needs to be established. And it needs to be uniform for all four factors. Right? So you don't want births by day and deaths by month, right? Your maths won't work. And so if we were to put this in formula form, population growth as a whole equals births minus deaths plus immigration minus emigration. Right? So the births and the immigrations are the things that would bump the population up, whereas the deaths and the emigrations are the things that would bring the population down. Yeah. Now this total number can be a negative number, and that means that the population growth is a net loss. There are less individuals in the population at that point in time than there were before. Okay? Now, when we're looking at populations in the way that they grow, left unfettered, right, and given all the resources they could possibly want, a population will grow at an exponential rate. Okay? And so if you start with one organism, you could get two. Those two would then make four, and those four would make eight, and so forth and so on. Right? And so by the fourth generation, I've added 14 individuals to the population rather than just four. Right? So if I was at 5, that would be a linear growth, straight line. If it's not a linear growth, it's an exponential curve, which you can see right here. Right? Exponential curve. Right? So if a population is left to its own accords with its own resources, that's what will happen. That's how it will grow. Okay? Now, obviously, in nature, the population isn't always going to have an infinite amount of resources. Okay? Eventually, the population is going to reach a size where there's just not enough of something for that population. So it could be food, it could be space, it could be water, it could be sun, anything that that population could need in order to survive, it might run out of because there's just too many of them, right? That moment where we hit where the population can't grow anymore because of the limitation of resources.
Can your attention please, park lunch is Saturday, so it should be the library, room 105 to 148, gym, 300 to 317, mod 1 to 3. Head to lunch, please.
It's lunchtime for some people. And so when we get to that point where the population can't grow anymore because it's run out of some resource, that's called carrying capacity. Okay. If you look at the graph, you'll see that it grew exponentially. The population size grew exponentially. Eventually, it hit this carrying capacity. It will go up over carrying capacity a little bit, and then some things will die, and it will dip under, and then they can have more. It will go over, some things will die. It will go under and over and up. It will hover in this kind of oscillation pattern. Okay? The longer the time goes on, the smaller the oscillations get, but they'll always kind of hover around this carrying capacity level. Yeah? So that's carrying capacity. Yeah. That's it. Bye.